So this is still Unit 3, Day 2. We want to find the derivative of logs. Like that's the shorthand version of today. Derivatives of logarithmic functions. Alright, in this section we consider logarithmic functions. Logs like trig and inverse trig are called transcendental functions as opposed to algebra functions. I don't really know why they're called that, or more importantly, why you would even need to know why they're called that. Get my picture back in. So let's worry about, or let's sort of back up and review some log properties, because this is where some people struggle. So let's make sure we got our background set first, and then we'll move into calculus. So log properties. This is pre-cal and algebra 2 stuff here, but it's worth taking the time to remember. Natural log is a log of base. So what's the missing base there in a natural log? Do you remember? E. Right? It would be the same thing as writing log base E of x, but nobody ever writes that because we have natural log in place of log base E. What about natural log of E? 1. That means E to something is E. Well, E to the first is 1. Natural log of 1 means E to what would be 1? 0. Domain. We'll get to that in a minute. Let's back up and do properties. Natural log of xy. Do you remember how you can split it up? Here's it. Natural log of x plus natural log of y. Logs and exponents have that weird properties of addition and multiplication sort of combining. Natural log of x over y is natural log of x minus natural log of y. And then what about an a out front? I feel like we usually use this the other way. So that it can be the power. Natural log of x to the a. I mean, you need to know all of those, but when it comes to taking derivatives, these are super important because you can avoid using, like you can avoid the product rule if you split it up first. If you do algebra first, then maybe, I hope it makes sense, that taking a derivative of this is a whole lot easier than taking a derivative when it's together. So a lot of times we'll do the algebra stuff first and then do the calculus, because it just makes life easier. Domain and graph. I think I would rather do the graph first, and then we can talk about domain. We said the natural log of 1 is 0. So there's 1, 0. And the natural log of e is 1, so that means e comma 1 should be on my graph somewhere. E is 2.7-ish, something like that. That's 2 points, that's not much. Do you remember what the graph of a log looks like? There we go. I see a few hands waving around that I think you're doing the right thing. So there's the graph of a log or a natural log. So the domain is x has got to be bigger than 0. Or if you want to be fancy, 0 to infinity. Okay, some more pre-cal stuff, / calculus stuff with limits. As x approaches 0 from the right, what's my graph doing? As x gets closer to 0, but a little bit more than 0, where's the graph headed? Negative infinity. And as x heads off to infinity, what's the graph doing? Headed to infinity. Very slowly, but headed toward infinity. So that means, at least this one means that there's a vertical asymptote at x equals 0. Okay. None of that is calculus. None of that is derivatives. But all of that is helpful to making sure we have our foundation laid so that we do take a derivative and start plugging things in and using properties that we're okay and comfortable with our logs. Okay, this stuff down here is like if we had a block day to do this is kind of an interesting way to get there, but it's probably easier to just give you the answer, and that is the derivative of the natural log of x. We did this last year? Did we get? So do you remember what it was, or what it is? Been too long? 1 over x. Somebody remembered it over there? So the derivative of natural log of u, so now we're going to have to use the chain rule, but it's the same process. It's 1 over the argument times the derivative of the argument. 1 over the argument times the derivative of the argument. Again, this is that is a chain rule thing. A result of the chain rule. Now, a lot of people will memorize this rule as u prime over u because that's a little bit easier to memorize. I will almost always write it like this because that sort of keeps the chain rule fresh in my mind when I write it like that. Obviously, those are the same thing. Again, to me, this writing it like this separates the rule from the chain rule. When you simplify it, it maybe gets all jumbled up, which is fine. It's still right. So either one of those, they're identical. One kind of emphasizes the concept, the other simplifies things. Okay, well that's just the base of E, which we like the base of E because it makes things nice, but we don't always have a base of E. So, again, we could go through log properties, but I think it's easier if we just fill in the blanks here. Natural log, derivative of natural log is 1 over x. Derivative of natural log of u is 1 over u times u prime. Log base b of x. Okay, so we have a different base. Alright, so it's still 1 over x. That rule still applies. But here's the new thing. It's also 1 over natural log of b, whatever that base is. So another reason to prefer natural logs, because you don't have to worry about that. This bottom right one, there should be a u right there. That way we can work on our chain rule and remind ourselves what the chain rule is. So 1 over u, 1 over the argument, times the derivative of the argument, times 1 over natural log of the base. Again, you can sandwich that up a little bit, but then you sort of lose the concept of the pieces. So it's up to you how you write it, but this is how I remember it. The log rule is 1 over the argument times the derivative of the argument, and then 1 over the natural log of the base. Okay, well, maybe that looks like 4 different things, but really, if you memorize this one, that covers all of them. That covers all of them. Because if it's natural log, what did we say the base was in a natural log? E. And what's the natural log of E? 1. So if it's a base E problem, then that piece goes away anyway. So you don't memorize 4 things. You remember one thing and know that it simplifies kind of depending on the problem. Okay, so yeah, that box, especially that orange box, deserves all the stars and colors that you got. That's what we got to know for today. Okay, some examples. Find the instantaneous rate of change. Again, we just like to keep using all the different words for derivative there. Y equals natural log of that thing when x equals 2. Okay, so dy dx. I'm going to put it in words because some people it helps to see the words. Let's back up just a second here. Using the chain rule, 1 over the argument times the derivative of the argument times 1 over natural log of the base. That's the same thing as the orange box there, but some people, it helps them to see the words rather than the symbols. Okay, back to this one. So 1 over the argument, 1 over 3x squared minus 4x minus 1. All right, it's kind of the chain rule thing where you do one thing at a time. So 1 over the argument. Don't mess with the argument yet. Then chain rule that to 6x minus 4. And the base is e, so I don't have to worry about any more than that. Again, it would be easier if I would just write it as u prime over u. But I feel like I lose sight of the chain rule when I start doing that. Why am I not done with that problem? I need to plug 2 in. Here's some more new notation here. dy dx, if you draw a bar and write x equals 2, that means I'm going to evaluate dy dx at x equals 2. 6 times 2 minus 4, 3 times 2 squared minus 4 times 2 minus 1. Right, there's my safe stop. Why risk making a mathematical computational error when I don't have to? But multiple choice is going to clean that up. 12 minus 4 is 8. Let's see, 12 minus 8 minus 1 is 3. So, left up to my own devices, I leave it as a safe stop, but for a multiple choice answer, I better be able to simplify. Number 2, that's ugly. Natural log, cube root, x cubed minus 3x. Slope of the line, tangent to the graph. So again, that's just asking for a derivative. But I can make this problem easier. I can make this problem a lot easier with one of the properties. Do you see what property I could use to make it easier? Rewrite this. X cubed minus 3x. What power is the same thing as a cube root? 1/3. And then where can that 1/3 go? Out front. And so this is a lot easier. Before I make that algebra swap, I would have to do 1 over this thing, and then the derivative of that thing would be really ugly. But if I move the 1/3 out front, I haven't taken a derivative yet. I'm still just doing algebra. 1/3 natural log x cubed minus 3x. This is going to be a whole lot easier now. So g prime 1/3 goes along for the ride. 1 over the argument x cubed minus 3x times the derivative of the argument 3x squared minus 3. That's my safe stop for sure. What would be done to get to a multiple choice answer? Like, what could we do to simplify? Do you see? Hopefully you'd recognize the answer on the multiple choice test. That bottom 3 can divide into those top 3's and get me x squared minus 1 over x cubed minus 3x. So again, free response versus multiple choice. Safe stop versus having to clean it up a little bit. Number 3. it looks like we're going to have to use the quotient rule. Right? So the ugly way would be, and I'm not doing this, so don't write this down, but be 1 over the argument, and then we'd have to use the quotient rule on that thing. So that'd be terrible. Instead, let's do algebra first, and split this up into natural log of 2x minus natural log x plus 3. Much nicer. So h prime of x start calling on some people here. So 1 over the argument, so 2x is in the bottom. Justin, we ease into the day with, what's the derivative of 2x? 2. 1 over the argument. We're really easing into the day now. Luke, what's the derivative of x plus 3?
Just 1.
Just 1. So that one's kind of done. Uh-oh. Well, maybe uh-oh. I'm starting to look at my answers, and none of them match what I wrote. So how do I get from what I wrote to what my answers are? I need a common denominator. I can also reduce that 2 there. So my first fraction needs an x plus 3 top and bottom. And my second fraction needs an x in the top and the bottom. So x plus 3 minus x over x and x plus 3. Certainly no one is tempted to cancel the x plus 3's, right? We're not doing that. Right, that x plus 3 in the bottom is eligible to be canceled, but the top one is being added and subtracted, so don't do that. X minus x goes away. 3 over x times x plus 3. And that is one of my answer choices. This is one of those calculus is easy, algebra is hard problems. Because, let's see, we did an algebra step, and then a calculus step, and then algebra and algebra. So the problem was like 3/4 algebra and 1/4 calculus. And of course you got to get them all the pieces right to land for the answer. Number 4. Find dy dx if y equals natural log of the secant of x. So 1 over the argument. Alright, Ava, we go from asking people for the derivative of x and 2x to the derivative of secant. So you're really on the spot here. What's the derivative of secant? Don't know? Secant tangent, yes. Secant x, tangent x. Oh, well that was convenient of them. Secants will cancel, and we're left with this tangent. That was kind of nice. Uh-oh, what makes number 5 different than the ones we've been doing? It's not natural log. The base is 7, so I already know there's going to be a natural log 7 in the denominator of my answer somewhere. So let's see, f prime of x. 2 is just going along for the ride. 1 over 3x to the 5th. Everybody's back on the draw side of things now. So, Ashlyn, what's the derivative of 3x to the 5th? 15x to the 4th. And then I need a natural log of 7 in the denominator. Now that looks... Actually, there's nothing wrong with that answer. It's just kind of strung out, spread out, weird looking. So we should clean that up. Well, we shouldn't clean it up, right? Like that. That would be my safe stop answer. All the pieces are there. Don't mess it up. Multiple choice. Let's see. 15 over 3 is 5. Times 2 is 10. X to the 5th in the bottom. X to the 4th in the top. So what happens? What am I left with, and where are the x's, Jameson? What's that? The x in the bottom. So that took care of the 2, the 3, the 15, the x's, and then there's a natural log of 7 in the bottom as well. So that's a pretty significant difference from the safe stop to the multiple choice answer. Again, nothing wrong with safe stop, but you need to be able to get from safe stop to the multiple choice. Oof, number 6. Lexi, big picture. What rule do I need for number 6? What's that? Yes, I will need that one. But I think even before I get started into the details, what's that? What's quotient mean? We are multiplying, so which one of those fancy words means multiply? Anybody? Product rule. So this is product rule plus power rule plus log rules plus a base that's not e. So there's a lot of things going on this problem. Okay, first times derivative of the second. So 3x derivative of the second. So x squared plus 7 in the denominator. 2x in the top. And Holly, what else do I need to finish that derivative? And where does the natural log of 5 go? In the denominator. So I'll just throw it down there with the rest of the denominator. Okay, so that was FG prime. Now I need to go the other way around. Oh, this one's going to be a lot easier. Someone gets the easy stick here. Ben, what's the derivative of 3x? 3. And then I don't have to do anything with g. I just rewrite it. Log base 5 of x squared plus 7. And that's an ugly answer, but who cares? We did what they asked. Safe stop. We're good. And really not a lot of cleanup you could do. Right? 3x times 2x is 6x squared. That's about the only thing you could simplify. Number 7. Ooh. That looks... If we tried to do that without doing algebra first, that would be terrible. Right? Because it's quotient rule, but also product rule. So let's split this thing up. Let's do algebra rule first. Okay, so that's x. The times in the top, so that's going to be plus natural log square root x squared minus 3 minus natural log of cosine of x. And there's still one more algebra step I can do. Ambria, what else could I do before I take a derivative that will make my derivative life a little easier? It's kind of hidden. We did it earlier, but it's definitely kind of hidden. Here's your hint to unhide it. Good. Make it a power of 1/2, and if it's a power, it can come out front. So 1/2 natural log x squared minus 3 minus natural log cosine x. need to keep labeling these because I'm about to switch from F to F prime, and if you don't have them labeled, I don't know when you made the switch, and it's hard for me to grade what's going on. Now we're ready to take a derivative. I can call on some more people. Johnny, how about the derivative of natural log of x? So the derivative of natural log is 1 over the argument times the derivative of the argument. What's the derivative of x?
1.
Just 1. All right, how about the derivative of the natural log of x squared minus 3, Addie? Good. Uh-oh, somebody's about to catch the trig function here, Aslan. What's the derivative of natural log of cosine? Right? Yes. He said that backwards from how I would have said it, but that's okay. He jumped ahead. 1 over the argument times the derivative of the argument. And again, that's a safe stop, so you're fine to just leave it like that. Multiple choice would probably clean that up a little bit. 3 over x. The 2's would reduce. Negative and negative is positive. You know what? This is a good one to simplify because multiple choice, what's sine over cosine equal to? Tangent. So usually getting from safe stop to multiple choice is pretty easy, but occasionally something like that happens where, again, that's not too bad, but hopefully you recognize what happened there. Yes, sir. Yes, thank you. I left off the 3. I did not distribute the 3, so the 3 and the 3. What else did I miss? Yep. Glad you guys are paying attention. Number 8, and final. The graphs of f and g are shown over here. If h is natural log of g over f, find h prime of 1. What do you want to do first for this problem? What's that? Make it cleaner. What do you mean by that? I think I agree with you. Definitely. Natural log g of x minus natural log of f of x. So that's just an algebra step, but it's going to make the derivative so much easier because now we just got out of having to do the quotient rule. So h prime is 1 over g of x times g prime of x minus 1 over f of x times f prime of x. And then at 1 just means plug 1 in everywhere. Let's see if we can do this on the fly here. G prime at 1. Okay, G is this one. So what's G prime at 1? Negative 1/2. The slope at 1 is negative 1/2. G of 1. Oh, this is kind of annoying. What's G of 1? 3/2 or 1.5, or the 3/2 is probably better since we're already dealing with fractions here. Minus G stuff, F stuff I'll do in green. We're still at 1, so right here. This one's a little bit easier. Let's pick on 2 more people here. Austin, what's f prime at 1? Negative 1. And Brooke, what's f of 1? 6. So that's a good enough safe stop, but obviously it's multiple choice. 1/2 divided by 3/2, that would be 1/3 plus 1/6. Whoops, negative 1/3 plus 1/6. I'm trying to keep a change of flip it in my head, and that's a terrible idea. But I got it right. Negative 1/3 plus 1/6. So that would be negative 2/6 plus 1/6 would be negative 1/6. That. Algebra, calculus, graph, calculus concepts, algebra concepts, fractions, fractions, fractions. All the things built into number 8. Alright, worksheet number 2 is today's assignment. Again, the main rule today is the derivative of the log of something is 1 over the something times the derivative of the something. 1 over the argument times the derivative of the argument. Also in the bottom, I guess we should be careful, natural log of whatever the base is. So there's the rule right there. Should have just put that on the board and been done for the day. Alright, block day tomorrow, so we'll have plenty of time to answer questions, and tomorrow's lesson is exponents. Logs and exponents kind of go together, and so there's some parallels between what we do tomorrow and what we did today.